Hello everyone, welcome to our daily physics problem, day 16. So today we are going to look at a problem that talk about the magnetic field and the trajectory of a charged particle. So here we have a positive charged particle with Q and mass m, and then it's starting from rest and accelerated through a source by a potential difference, then entering into a magnetic field, bended, enter out, accelerated again because it have a large velocity, enter to a second magnetic field, have a large radius, trajectory, and then finally enter out. And we want to find, based on the velocity, voltage, and the trajectories, calculate the ratio B2 over B1, the magnitude of the magnetic field in different regions. And we know that R2 is equal to 2R1. So it's a very hard problem. I want to try it on myself. After you try it, come back to the video and I'll show you how I did it. So welcome back, guys. So first, let's just start off and calculate the ratio between the magnetic field. And we use some symbols first because we only know the symbols. Only thing we do know numerically is our relationship between R2 and R1. So let's try to express it in variable form. So based on the trajectory centripetal force equation, we can equivalent the magnetic force and the centripetal force. We can find out our expression for B2 and B1. Then we just plug it in. B2 divided by B1 M times V2 divided by QR2 divided by MV1 divided by QR1. Cancel out the M and Q's. We got V2 times R1 divided by R2 times V1. Let's group the terms together. V with V, R with R. Then we find out that R1 over R2 we already know, which is 1/2, based on the R2 is equal to 2R1. But we don't know the V2 over V1 yet. So all we need to do is solve for V2 divided by V1 based on the acceleration given by the voltage difference. And we know that the voltage difference are the same. That's a very crucial point. So we can use some energy equivalency. So we know the kinetic energy given by of the particle is given by the electric field by Q times changing V, which is the potential difference times Q will be the energy added. Then 1/2 mv2 squared will be twice the Q times changing V because it's accelerated twice and it's starting from rest. So we can use this would be the right, use them equivalent. We can know m times v1 squared equal to 1/2 mv2 squared. Cancel out the m, get 2, and then we know that v2 divided by v1 is square root of 2. So now let's plug it in. We got our final answer. b2 over b1 is square root of 2 times 1 over 2.